In this video, we're going to understand the equation y equals mx plus c and use it to find the equation of any straight line. So here in the purple box, you can see the equation y equals mx plus c, where m is the coefficient of the x, that tells us the gradient, and c is the y-intercept, which is the point that cuts the y-axis. Now let's do some examples where we find the equation of each of the straight lines in the form of y equals mx plus c. So the first one, it's very simple. If we already know the gradient, we're given the gradient, in this case it's -2 and the y-intercept is 3, then it's just a case of writing it in the form of y equals mx plus c and substituting it in the gradient, m, for -2 and the intercept for 3. So the equation therefore becomes y equals -2x plus 3. Now the second example says that in this particular time we've got the line passing through one single point and we've been given the gradient. So in this instance I'm going to write the equation y equals mx plus c with the known gradient, so it becomes y equals -2x plus c. Now I have a known coordinate which is 1 minus 3. This, don't forget, is the x value, so that's x equals 1 and y equals -3. So I'm going to use that known point in this equation to find c. So let's sub in -3 equals -2 times 1 plus c. Let's work that out. Now, if I take the 2 across, I'm going to add 2, which leaves me with c equals 1. Oops, let's put that little minus in there. Sorry, c equals -1. So now let's rewrite the equation of the line as y equals -2x minus 1. Our third example is where we don't have any other information about the y-intercept or the gradient, but we do have two known points. Now, if you've watched the video on finding the gradient, then you'll know that the gradient is y2 minus y1 divided by x2 minus x1. So we take this one as the first coordinate, so this is x1, y1, and this is the second coordinate, so we call this x2, y2. So now it's just a simple case of substituting in the values. So y2 is -2, and we need to take away y1, which is 6, divided by x2, which is 3, take away x1, which is -1. So obviously this becomes a plus here. So I get on the top -8 divided by 3 plus 1, which is 4, leaving us the gradient as -2. Now, what we can do is write in, similarly as the example above, we can say now that the equation of the line is y equals -2x, because remember that's the gradient that we've just found, plus c. Now we can use one of the known coordinates, probably this one. You can use that one if you want, but I'm going to use this one to sub it in. So obviously my x value is -1 and my y value is 6. So let's sub that coordinate in. 6 equals -2 times -1 plus c. 6 equals -2 times -1 is +2. Sorry, I've missed the... Oops, hang on. Just having a little error there. And then I've got plus c. Now I'm going to subtract the 2 over, giving me 4 equals c. So with my gradient and my y-intercept, I can now say that the equation of the line is y equals -2x plus 4. And a final example is when you've been given the actual graph itself. Now, I should have labelled that the x and y axis, so that's important. And obviously, if you see my other videos, you know that lines are continuous, so they should have arrows on them. So we're going to find the equation of this line. Now, we have two known coordinates. This one is 1, 4, and this one is 0, 1. Now, I can do this visually, or I can do it using the formula above, but we know that gradient is basically rise over run. So let's have a look at the rise. The rise in this case is 3, and the run in this case is 1 between the 2 points. So my gradient is 3. Positive direction. Now, the y-intercept is 1, so I've got c equals 1. So now I have the y-intercept and the gradient. I can say that the equation of the line is y equals 3x plus 1.